Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's challenging level puzzle. And it's called The Odd One Out by Bellamus. And here are the rules. Normal Sudoku rules apply, which means fill every row, column, and box with the digits 1 through 9 without repeats. Killer cages. In killer cages, digits do not repeat in cages. And that's because we don't have any clues on the... It's similar to yesterday's puzzle, where we don't have any values in the actual... for the killer cages. But in this case, we don't know if there are single digits or double digits either. But we just know that you cannot have repeats within cages. Crop key. Digits in cells separated by a white dot are consecutive. Digits in cells separated by a black dot have a 1 to 2 ratio. So for example, if this were a 6, this would have to be a 5 or 7 to make sure that these two digits are consecutive. If, for example, this were a 4, this would have to be a 2 or an 8 to maintain the 1 to 2 ratio between them. And that's how crop key dots work. And finally, when two cages are orthogonally adjacent, both cages have the same sum and no digits are shared between the two cages. So for example, between this cage and this cage, orthogonally adjacent means that they just share an edge. And so this cage does share an edge with this cage, so it's orthogonally adjacent, which means these cages are the same sum, and no digits can be shared between this cage and this cage. So that means all 4 of these digits must be different than all 3 of these digits. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. So, we know this is the same sum as this. This is the same sum as this. But interestingly enough, so these 4 digits must be different than these 4 digits. Well, these 2 digits cannot be any of these digits, and it can't be that digit because they both see that one. So these 2 digits must specifically be the same as these 2 digits. Well, this is in a 1 to 2 ratio with this digit, so that means this must be in a one of these digits must be in a 1 to 2 ratio between both of those digits. Because this is a separate digit than these two. This digit is in a 1 to 2 ratio with this one because of that relationship there. And we know this one is also in a 1 to 2 relationship with this digit. So this is in a 1 to 2 ratio with this digit, and it must be in a 1 to 2 ratio with this one. So this is specifically 1, 2, or 4, or 2, 4, 8. So this is either 1, 2, 4. So this would be 1, 2, and 4. Or this is, or it could be 1, 2, 4 this way, or it's 2, 4, 8, or 2, 4, 8 this way. Either way, again, this is 1, 2, 4, or 2, 4, 8. So this can't be 8. We don't know much of anything else, though. These, let's make these actually gray. These 4 is orthogonally adjacent to this cage. So these 4 cells cannot be the same as these 4 cells. So this cell cannot be this one, cannot be any of these, and it can't be here. So it must be this one. And this cell cannot be any of these 3, can't be any of these, and it can't be this one. And it cannot be the same as the green because, again, remember, there are no digits shared between those two. So it can't be the green, so it must be this one. Therefore, we know this one matches this. So red has to be one of those 3. Green has to be one of these 3. Okay, so this sum is the same as that sum, which is the same as that, which is the same as that. This digit cannot be the same as these 3 or that one from Sudoku and the killer cage, and it can't be the same as that one. So this one has to be the same as this. These 2, right? What else do we know? This one cannot be any of these 3, and it can't be these 3, and it can't be that one because it can't be the same as that one. So this one must be one of those 2. Also. Okay. That means the orange one is here. One of the gray ones must be here, and the other gray one has to be here. We're not sure which one's which, though. Anytime we know these 2 sum to each other. What happens if this is 1 and 2? If this is 1 and 2, and they sum to each other, the same number, this has to be an even number. This must be 1, 2, and this is 4. So I think that works, right? If this is 1, 2, That means this is 1, 2, and this would have to be 4. So 45 minus 4, 2, and 1, which is 7. 45 minus 7 is 38. Oh, no, that doesn't work. So again, if this is 1, 2, that means this specifically has to be 1 and 2, and this has to be a 4. So the remaining digits here add up to 45 minus 4 minus 2 minus 1, which is 7. So 45 minus 7 is 38. So this adds up to 38, but this is only 3. So therefore they add up to total 41, but they must sum up to the same number, which is not allowed. So this can never be 1, which means this can't be 1. So can it be 2, 4? If this is 2 and 4, well, let's try 4 and 8 first. If this is 4 and 8, that means this is 4 and 8, and this has to be 2. So the total of all of these cells would be 4, 2, and 8, right? Sorry, this is 4 and 8. This would have to be 4 and 8 plus, that's 45, plus 4 and 8, which is 12. That's 57. 57 minus 2, 4, and 8. Right, 57 minus 2, 4, and 8, which would be 14, would be 43. But then you'd have these cages, which have to be the same sum, adding up to 43. So 2 times the sum would basically be 43, which is not allowed. So this cannot be 2, 4, and 8 either. Or 4, 8, and 2 here specifically. Therefore, this has to be 2, 4, 2, 4, and 1, I believe, right? Because you have the same problem if this is 2, 4, which is an even number, and this is 2, 4, 8, right? Because you have an odd number subtract out an even number, which would make this an odd number. Therefore, this would be even plus an odd, which means the combined would be an odd number, which is not allowed to be 2 times another integer. Therefore, this has to be 1. So this is 1, which makes this 2, which makes that 4. So that works here then, right? This is 6, so this would be 51 for this cage plus these 2 digits. But the thing is, so that works, right? Because if we have 51, you subtract out 7, which is 4, 2, and 1. 51 minus 7 is 44, which is divisible by 2. So this has to be 22 for each. And this is 6, so this must be 16, which has to specifically be the 7, 9 pair, which means the rest of this is 3, 5, 6, and 8. This can't be 1 or 2 here. This specifically cannot be 1, 2, because again, neither of these could be 1 or 2. This cannot be green, because again, the green has to be in a 1 to 2 ratio with another digit. So this is specifically 3, 4, 6, or 8. Or it cannot be 8. This is 3, 4, or 6. If it's 3 or 6, the other one has to be 3 or 6. If it's 4, the other one has to be 2. Because it cannot be 8, but it can't be... Okay, so therefore this has to be 3 or 6. And this cannot be the green. Let's just remove all of the gray. This has to be 3 or 6. This is 3 or 6. 3 or 6 is consecutive with 3. If it's 3, this has to be 4 here. So this is actually, we have a 3, 6, 3, 6 pair here, which eliminates 3 and 6 from the rest of the column. So this can't be 3 or 6. This is 5 or 8. The red has to be here. This can be, if this is 3, this has to be 4. If this is 6, it could be 5 or 7. So that's fine. The rest of these digits cannot be, it has to be 3, 5, 6, and 8. Okay. So we know, interestingly enough, okay, so these also form the same set, or add up to a same sum. So this must be 2 times something. If you add these together, that's 9. These are 9 too. So okay, so this is an odd. This is 45, and you have 9 added to it, right? So that means it must be 54. If you take 54 and you subtract out 9, this is an even number here because these are the same sum. This is odd. And to add up to 54, which is an even number, you need another odd. So this has to be 5 or 7, which forces this to be a 6, which makes this 3, right? Because this has to be odd, it has to be next to an even number, so this has to be 6. And this is 3, which makes that a 3. So none of these can be 3. So we know we're removing all the reds. We know one of these is a 6. So this has to be consecutive with this, and it cannot be 1 and 2. Can't be 3. Actually, we don't quite know exactly how much this is. The remaining digits here can be 4. So this could be 4, 5. It cannot be 5, 6. It cannot be 6, 7. It could be 7, 8, or 8, 9. So this is 4, 5, 7, 8, 9. If this is 4, 5, okay, so what are the possibilities? This is 54 completely. Subtract out 9, so that's 45. If you subtract out 5, that would leave 40, so then this would be 20 each. If you subtract out 7, that leaves 38, so these would be 19 each. So if this is 4, 5, specifically, that means this is 7, so this must add up to 19. So if this is 4, 5, this would be 12, and we would need 7 to add up to 19, but that's not allowed because the 7 would be here. So this can never be 4, 5. This has to be 7, 8, or 8, 9. Either way, there's an 8 here. So 8 has to be one of those 3 then. If we have 3, 7, 8, the 7 is taken into account, so this would be 3. This would have to be 5 then. So you subtract out from 54, you would subtract out, or actually subtract out from 45, you'd just have to subtract out 5, so that would be 20. So this would be 3, 7, 8, and this would have to be 2. If this is 3, 8, 9, that's already 20, and no normal Sudoku digit could add up with it to add up to 20 or less. So this cannot be, this has to specifically be 7, 8, which makes this a 5. So 5 cannot be here. 5 can't be here. This must be 8, which means this can't be 8. This has to be a 2 to add up to 20. This can't be 5 or 8. This can't be 8, so this is 7, which makes that an 8. Therefore, this has to be a 4, 9 pair here. The remaining digits here have to be 1, 4, and 9, and this can't be 4 here, so this must be 4, which makes this a 1, 9 pair. This adds up to 20 also. So this is 20 and this is 20, and that works. This cannot be 9 because of the 1, 9 pair in the column. So this must be a 7, which makes that a 9. The remaining digits are 5, 6, and 8, and the only digits that can be consecutive are 5 and 6. So this is 5 and 6, and this has to be 8. The remaining digits here are 1, 2, and 7, and they could still be any of those. Okay. 8 cannot be here, and 8 cannot be here, which means 8 cannot be this, 8 cannot be here. 8 has to be one of these 4, but we're not sure which. 2 has to be one of these 3, and 4 has to be one of those 3. Okay. The 4s have to be completely different digits here for these cages. So it can't be obviously 10 and 10, can't be 11 and 11, can't be 12 and 12. What could it be? Okay, so the odd digit out from these 8s, because again, all 8 of these digits must be different. They add up to an even digit, right? Because it's 2 times some value. Therefore, this must be an odd digit. Because the orange has to be here, because it can't be that one, and it can't be any of the ones in the other cage. The pink has to be here, because it can't be any of these in the same cage, and can't be any ones in the different cage, and can't be the orange, so it must be one of these two. Therefore, this is the odd digit out, which means it must be odd. Because again, these must add up to an even digit. With the odd one out, it has to be odd. So therefore, this must be 1, 5, 7, or 9. Well, that must be consecutive with an even digit, and it cannot be 2 or 8 here, so therefore this is 4 or 6. Well, 4 and 6 is only consecutive with 5 or 7. 1 and 9 can only be consecutive with 2 or 4, or with 2 and 8 specifically, and neither of them can be here. So, what does that mean? These add up to 45 minus this number. So it's either 40 or it's 38. So this must be 19 or it must be 20. Either way, 1 cannot be in this 3 set because 1 plus 8 and 9 at most adds up to 18, which is 1 less than what we have to have. So 1 has to be one of these two. 1 cannot be any of these, so 1 could be any of these 4. Which, this digit has to be 1, 2, no 3, 4, 5, 6, 7, or 9. That's still pretty broad. Actually, what can this be? Okay, so it cannot be 4, 6, and 9, right? Because that would eliminate all possibilities for that cell. So that cannot be 19. Can it ever be 19 in another way, is the question. I don't think so, right? Because if you take no 9 here, then you have 4, 5, and 6 at maximum, which is 15, which is not allowed. So 9 has to be in this set. And if you have 9 with 4, like the only possibility with 9 to add up to 19 is 9, 4, and 6 here. Because you don't have a 7, you don't have an 8. So that eliminates 3, 7, 9, and 2, 8, 9. And those are the only ways you can get 19. So this has to be 20, which is 9, 5, and 6. Which means this is 20, and this is 20, which means the odd man out has to be 5. So this is 5, and this can't be 6, so this must be 4, which means 4 can't be here. This adds up to 20. If this were 4, the only two digits you could add up with 20 that are unique would be 7 and 9, but this can't be 7 or 9. So this can't be 4 then, which makes this a 4. So 1 and 2 both have to be here, which means 1 has to be one of these three. This has to be 1 or 3. So these can't be 6, which means this has to be a 6. This can't be 6. This has to be 1 or 3, and this is 1 or 3. And one of these is a 1. This can't be 5 anymore. So this adds up to 20, and this adds up to 20. Well, the orange and the pink cannot be 4 and 6. 4 cannot be any of these. This can't be 6. This has to add up to 20. It could be 3, 8, and 9. But if that's the case, this would be 3. This would be 8 and 9. And this would have to be 5 and 6. That's possible. Or if it's with 5, it could be 5, 6, 9. Or 6, 5, 9. Or it could be 5, 7, 8. That also works. Right, the possibilities adding up to 20 are 3, 8, and 9 for 3 digits. 4, 7, 9, which is not allowed because, again, if you had a 4 here, this would have to be 7, 9, 7, 9, and that can't be 7, 9. 5, 6, 9, or 5, 7, 8. And those are the only possibilities because if you have anything with a digit higher than 3, 4, 5, you try 6, it has to be at minimum 6, 7, and 8, which is 21, which is not allowed. So it has to be some combination of these. Okay, so if it's 3, it requires an 8 with it. If it's 5, it requires a 6 or an 8 with it. If it's an 8, it requires this could be this can't be 3. So if this is yeah. So this cannot be 4 or 6 here, right? Because it's the same as the pink, and they both see this. This also cannot be 4 or 6. What could it be? It could be 1, 2. If this is not, say this was 3 here. This would have to be 5, 6, or 8. Except that the problem is if this were 5, 6, or 8, you would have to have another 5, 6, or 8 here. So I don't think this can ever be 3. If this were 3, that would mean this is 5, 6, 8. But this 5, 6, 8 would have to add up to 20 with these digits, which is not allowed. Oh, this is 5, 6, and 9. So this cannot contain a 9 or a 6. Which means to add up to 20, it's specifically 2, 8, and 3, 7. Because 4, 6, and 1, 9 are not allowed. And we know these have to add up to 20 as pairs of 10s, because the only remaining digits here are essentially, yeah. Well, not necessarily. But I think it's really hard to come up with some combination. Okay, well, this can't be 6, 5, 6, or 9. So because of that, we know this cannot contain 5, 6, or 9. 5 is over here. Where are the 6 and 9? They can't be here, and they can't be in here, so they have to specifically be here, which means this can't be in 6, so this is 9, which makes that a 6. So the remaining digits are 1, 2, 7, and 4. Oh, well, actually, you do know, actually, this can't be 4. This has to be a 4, then. Because this can't be 4. Never mind. You don't have to have that, then. Okay, so what is 4? You don't have a 6. You don't have a 9. You have 4. How does that work? This obviously cannot contain a 4. You have to have 2 out of 1, 2, 7. So, ooh. So you cannot have 1 and 2. So that means the 7 has to be here. Right? If you try to have 1, 2, that just doesn't work. That's 7 by all those 3 themselves. So 7 has to be here. So you have 7, 4. You would have to have 1 with it, right? If you try to have 7, 4, and 2, that would require another 7 in the cage, which is not allowed. So this cannot be 2. This is 1, 7, 4. That means this has to be 8, which means 8 can't be here. So this is 1 or 7. We have a 1, 7, 1, 7 pair in row 6, which eliminates 1 and 7 from the rest of the row. So this must be 2, which means this can't be 2. This cannot contain a 1, 2, 4, or 8. Sorry, 1, 4, 7, or 8. So it must be specifically, what, 2, 3, 6, and 9. Which does add up to 20. So this can't be 1 here. 2, 3, 6, and 9 means you cannot have a 9 here in this set, which means that it has to be 5, 7, and 8. So this has to be 5, 7, and 8 as the only set of 3 digits which add up to 20 without a 9. So this can't be 8, therefore this is an 8. This 5, 7, 8 triplet eliminates 5, 7, and 8 from the rest of the box. So therefore this can't be 5, 7, or 8, so this is 3. This can't be 5, 7, or 8, or 3, so this must be 6. So this can't be 3 or 6. This has to be 2 or 9. This is 1, 2, or 9. This is 1, 2, or 9. This can't be 7, so this must be 5, which makes that 7. This can't be 3, 5, or 6, so it must be 8. So this is 1729. Therefore, the rest of the column cannot contain 1279 because we have a 1279 quadruple in column 7. So therefore, this must be an 8 because that's the only place for 8 that can be there. This can't be the orange. The orange has to be one of those two. The remaining digit has to be a 5. So this is a 5. Okay, the remaining digits here are 1, 9 with 5 or 6. This can't be 9. This can't be 6. This can't be 6. Remaining digits here are 5 and 6 with 3 and 7. And these can't be 6. So one of these two is a 6. The remaining digits here are 1 through 5. And can't be 1 through 4 and 7. Sorry. So this can't be 4. These can't be 3. These can't be 6. So now we have, where is the 6 in box 6? It has to be here. So this is 6. We have a 2, 3, 9 triplet in column 9, which eliminates 2, 3, and 9 from the rest of the column. Therefore, this must be 1 and 7 remaining. We have a 1, 7 pair now in box 9, which eliminates 1 and 7 from the rest of the box. So this can't be 1. This has to be a 3, which makes this a 1. The remaining digits are now 2 and 9. So this is 2 or 9, which we have a 2, 9, 2, 9 pair, which eliminates 2 and 9 from the rest of the column. So this can't be 2 or 9. This has to be 1, which makes this 2 or 9 also. These can no longer be 1 because of the 1 here. This can't be 1, so this must be a 5, which makes this a 1, 9 pair because those are the only places that 1 and 9 can be now. This can't be 5. This has to be 6, which makes this a 5. And again, these can't be 5. Therefore, this has to be a 6 because that's the only place for it. What else do we have? What can this be is the question. Remaining digits here are, one of them has to be 8. And this can't be 8, so therefore this must be an 8. And then we have 2, 3, 4, and 7. This can't be 6, so this must be 5, which makes that a 6. Five has to be one of these two. The remaining digits here, so one of these is 5. The rest are 1 through 4 and then 7. Right? Okay. This is another unique digit. And it has to be one of these two. We know it cannot be here and cannot be here, so it has to be one of these. We're not sure which, though. So these two sum up to the same sum. If this is 2, can this ever be 1 through 4? Probably not, right? Say it's 4, which would be the highest one out of 1 through 4. Then that would be 12. Well, it could be 1 and 3 here then, which would make that 7. Hmm. Okay, so if this is 2, it cannot be 1 through 3, right? If it's 2, 6, and 1, that adds up to 9, and this is already 9 with these two digits, so that's not possible. If this is 11, you can't have 2 and 2 here because there are no repeats in the cage. So if you have 2, 6, and 3, that would add up to 11, and therefore this would have to be 1, 8, and 2 to add up to 11, but you have a repeat of the 2 between the cages. You would share the 2 then between the cages, which is not allowed. This could be 2, 4, 6, though, and this would be 1, 3. That actually does seem like it works. What about 2, 6, 7? If this is 2, 6, 7, that's 15. So then this would be 3, 4, and 8. And that does work there. So this works with 2 and 4. In this case, this would be 1, 3. And this would be 2, 5, and this would be 7. This works with 2 and 7, in which case this would have to add up to 15. So this would have to be 3 and 4, adding up to 15. And then this would be, again, 2 and 5. And this would be 1. If this is 9, obviously this can't be 7 because then that would be 22. And there's no way this 28 would add up with 3 and 4, add up to 15. So it could be 9, 6, 1, which would be 16. And this could be 1. No. It cannot be 1, 7 then. It cannot be 2, 6. It can't be 3, 5. So this cannot be 9, 6, 1. So this can never be 1 here because we tried it with a 1. 2 doesn't work with 1, and then 9 doesn't work with 1 again. Because if this is 9, 6, 1, that means this has to add up to 16. So the 2 digits here have to add up to 8. The only 2 that would work would be 1 and 7, but we already have a 1 there, so that's not allowed. If this is 9, 6, 2, I think you have a similar problem, right? If you have 9, 6, 2, that adds up to 17. So these two would have to add up to 9, but the only 2 digits that do are 2 and 7. So this doesn't work 9, 6, 2, and it doesn't work obviously 2, 6, 2. What about 9, 6, 3? If this is 9, 6, 3, that means this is 18. So these 2 digits must add up to 10. And this would have to be 3, 7 also. So that doesn't work either. And so 2, 6, 3 doesn't work either. So if we tried 9, 6, and 4, similarly, this adds up to 19, and the only 2 digits would be 4 and 7, so that's not allowed. So this can never be 9. This has to be 2, which makes this a 9, which means 2 cannot be here. This can't be 9. We know 2 cannot be in either of these cells, so 2 has to be one of those. Therefore, this cannot be the blue. This has to be the blue and is 2. So obviously there's no 2 here. If this is 4, that means this has to be 1, 3. If this is 7, that means this is 3, 4. And it can never be 7 here then. So this can't be 7. This is 1, 3 or 3, 4. And this has to specifically be 2, 5. 3 has to be one of those two. 3 has to be one of these two. Where is the 3 in column 6? It has to be here. So this is a 3, which means this can't be 3. 7 is one of these two cells here, which means 7 cannot be in the rest of the column, so this cannot be 7. This cannot be 2, so it's 3. This 3 means this can't be 3, so this is a 4, which makes this a 2, which makes this a 4. This 2 and 4 means this can't be 2 or 4, so this is 7, which makes that a 2, which makes that a 4. This 2 means this can't be 2, so this is 9, which makes that a 2. This is, and we can remove the oranges and the pinks. This can't be 7 anymore, so this is 1, which makes that 7. This 1 means this can't be 1, so this is 9. This is 1. This 7 means this can't be 7, so this is 3, which makes that 7. This can't be 4 anymore, so this is 7. This 7 means this can't be 7, so this is 1. This 2 means that can't be 2, so this is 5, which makes that a 2. This 5 means this can't be 5, so this is 9, which makes that 5. This 1 forces this to be a 9, which makes that a 1. This has to be a 3. This can't be 7 anymore, and now we just do Sudoku. So this can't be 7, this is 1, this is 7. This can't be 4 because of that 4, so this is 9, this is 4. This can't be 1 or 7, so this is 9. This can't be 7 or 9, so this is 1, and therefore that forces this to be a 7. And that's the solution. Yeah, pretty interesting puzzle. I do like that the odd one out was the odd one here. I guess this was also the odd one out too, which was odd. And this was the odd one out, which was odd also. So everywhere there was an odd one out, it was always an odd one. Clever. Yeah, I wasn't a big fan of this part, but it makes sense. Pretty cool. Pretty cool way of doing it. It was the odd, every odd one was essentially an odd one out. So, sorry, every odd one out was an odd one. So, pretty cool about how that worked out. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.